Our first question is find the critical number of fs. To find the critical number, we have two steps, which means first we need to find the derivative of the fs, and second, derivative must equal to 0. Our function is x cubed minus 6x squared plus 9x minus 8. To find the derivative, I just use power rule, which means the coefficient must multiply with exponent, and then I reduce 1 the exponent, which means I get the derivative is 3x squared minus 12x plus 9. That is our first step. We get our derivative. Second step is the derivative must equal to 0, which means 3x squared minus 12x plus 9 is equal to 0. And then we get x minus 1, x minus 3 is equal to 0. And then we get our x is x equal to 1 and x equal to 3. So we conclude here our critical point are x equal to 1 and x equal to 3. For the second question is we need to find the point of which fs has a relative maximum. To do this question, we need to do number line. And the number line must related to the critical number that we find in recent question. So first, I do the number line. And we know that our critical number are x equal to 1 and x equal to 3. So I put x equal to 1 here and x equal to 3 here. So here is basically negative infinity and here is basically positive infinity. After that, we need to choose our test value. I choose the test value with the negative infinity until 1 is 0, 1 until 3 is 2, and 3 until positive infinity is 4. So this is our basically test value. After that, we need to substitute the test value into our derivative. So basically, we need to calculate f0, f2, and f4. And we just need the sign only. So after I substitute the value into the derivative, I get f0 is positive value, f2 negative value, and f4 positive value. So basically, if the function is positive, that is increasing. If the value is negative, that is decreasing. And same if it is increasing. So for relative maximum, we need to find function that increasing and then decreasing. So here we look, this is the relative maximum. So we know that our relative maximum is 1. So to conclude, point of relative maximum, we get our x is 1. And how to find y? We need to substitute 1 into our original function. This original function. And after I substitute, I get negative 4. So point of relative maximum is 1, negative 4. For the third question, we need to find the interval on which fs is increasing or decreasing. To solve this question, we need to find our critical number, and we already find it on question 1. So we know that our critical number are x equal to 1 and x equal to 3. So after that, we need to do a table with 3 columns. I do the table first. At the first column, we need to put interval. For the second column, we need to put derivative of fs. For the third column, we need to put fs. We know that we have 3 intervals, which is negative infinity until 1, 1 until 3, and last 3 until positive infinity. It's same as question number 2 that we have to choose our test value. For negative infinity 1, I choose my test value is 0. 1, 3, I choose 2. And last, 3 until positive infinity, I choose 4. So this is basically our test value. So after that, we need to substitute our test value into our derivative of fs. We just need the value, either it bigger than 0 or less than 0. And after I substitute, I get for negative infinity 1, the derivative is bigger than 0. For 1, 3, I get less than 0. And for interval 3 until infinity, I get the function is bigger than 0. And as we know that if it bigger than 0, it's actually increasing. And if it less than 0, it actually decreasing. And same, if it is bigger than 0, it actually increasing. So we conclude that fx is increasing at, we have to write here, at negative infinity 1 and 3 infinity, and fx is decreasing at interval 1. Question number 4, we need to find the concavity for the fs. To solve this question, we have two steps, which is first, we need to find second derivative of the fs, and second, the second derivative must equal to 0. So we already find our first derivative in recent question, which is 3x squared minus 12x. And we need to find our second derivative, which is we get our second derivative is 6x minus 12. That is our first step. And second step is the second derivative must equal to 0, which is here is 6x minus 12 is equal to 0. So we get our x is 2. So after that, we need to do a table that have 3 columns. So I will do a table first. For the first column, we need to put interval. For the second column, we need to put second derivative of fs. For the third column, we need to put concave. For interval, we only have 2 intervals, which is negative infinity until 2 and 2 until positive infinity. And it's same, we need to choose our test value. For interval negative infinity until 2, I choose 1. And test value for 2 until positive infinity, I choose 3. So this is basically our test value. So after that, we need to substitute our test value into second derivative. And we only want to know either it's bigger than 0 or less than 0. So after I substitute 1 into our second derivative, I get that it's less than 0. And after I substitute 3 into our second derivative, I get it is bigger than 0. And if the function is less than 0, it is actually concave downward. And if the function is bigger than 0, the concave is actually upward. The last question for the question 1 is we need to plot the graph using GeoGebra. So we need to open GeoGebra and put our function there. After I put our function in GeoGebra, I get this graph.
The second question is, two parallel sides of a rectangle are being lengthened at the rate of 2 inches per second, while the other two sides are shortened in such a way that the figure remains a rectangle with constant area A equals to 50 inches squared. What is the rate of change of the perimeter P when the length of an increasing side is A, 5 inches? So we can first start by drawing a diagram to help us visualize better. Then list down all the information given, which are A, which is also length times width, equals to 50 inches squared. dl over dt equals to 2 inches per second, and perimeter equals to 2 in bracket length plus width. Then the question wants us to find the dp over dt, which is the perimeter changing with respect to time. So write the equation as dp over dt equals to 2 in bracket dl over dt plus dw over dt. In order to find dw over dt, we can first start with the information of area equals to L times W equals to 50, which this can also be arranged as W equals to 50 over L. Then derive it as dw over dt equals to negative 50 over L squared times dl over dt. Insert the value for L and dl over dt, and we will get negative 4 inches per second for dw over dt. Back to our original equation, we can now substitute the value for dw over dt in the equation. And the final answer is negative 4 inches per second. For question B, which asks for 10 inches, the solution is similar to question A, but for the L value, we need to substitute the value of 10 inches. And the final answer will be 2 inches per second. And lastly, question C asks for the dimensions when the perimeter ceases to decrease. Here we will have the equation of dp over dt equals to 0. Then dp over dt equals to 2 in bracket dl over dt plus dw over dt. And substitute the value of 0 into dp over dt. So we will get dw over dt equals to negative dl over dt. And lastly, we will get negative 2w over L equals to negative 2. Hence, the rectangle is the square of the sides, which means L equals to W equals to square root 50.
Assalamualaikum and hi everyone. My name is Nur Aida Zubaika, the Muhammad Nazir, and my Nazir number is PC23905, and I will be representing for question number 3. For question number 3, the question is the total cost of producing X radio set per day is Rm1 over 4x squared plus 35x plus 25, and the price per set at which they may be sold is Rm50 minus 1 over 2x. Given here, the cost function which is Cx is 1 over 4x squared plus 35x plus 25, and the price per set is which is Px is 50 minus 1 over 2x, and we can get the revenue function which is Rx by multiplying the Px times x, and we will get 50x minus 1 over 2x squared. So for question A, what should be the daily output to obtain a maximum total profit? So question A asks for maximum total profit. So you can get the Px first, which is you need to minus Rx minus Cx, and we will get Px is equal to minus negative 3 over 4x squared plus 15x minus 35. And after you get the Px, you need to differentiate the Px, so you will get minus negative 3 over 2x plus 15. And after you differentiate the P, you need to equal it to 0, and the answer will be 10. Since the coefficient of x squared is negative, the profit is maximum at this value. So the answer is x. The answer for question A is x equal to 10. We will set 38. And for question B, show the cost of producing a set is a relative minimum at that output. So question B asks for cost per set is a relative minimum at head output. Okay, first we need to search for average cost first, which is AX is equal to CX over X. Okay, and you will get the answer is 1 over 4x plus 35 plus 25 per x. And you need to differentiate the average cost that you get. And you will get 1 over 4 minus 25 over x squared. And when x equal to 10, you will get the answer is 0 because 1 over 4 minus 25 over 100 is equal to 0. The derivative change from negative to positive. Hence, this point is a relative minimum. And the cost per set is a relative minimum when x equal to 0. That's all.
Okay, now for questions number 4. The question gives us limit x approaching 0, since 3x over 4x. If we put the 0 value in the question, then we get the indeterminate form 0 over 0. So we can use the Hospital rule. So the next step is we differentiate with respect to x, and we got 3 cos x, 3x over 4. And then we just put the value of x in the question, then we got 3 over 4. For question number 2, the question gives us limit n approaching infinity, 3e to n over 4n squared. And if we put the value n, we also get the indeterminate form, infinity over infinity. So the next step is we differentiate with respect to n. For example here, we got 6e to n over n. But then again, if we put the value of n, we also still get the indeterminate form. And by that, since we get the indeterminate form again, we must differentiate again with respect to n. So after differentiate this, then we got 12e the power of 2n over x. Now if you calculate this, then you can get 3 over 2 times infinity. So we get the infinity here.
Hi, Assalamualaikum. My name is Nur Shahzada Hafidhi Safavi. My matrix number is BC250719. So the question that I am in charge of is question number 4, which is limit x towards positive 0, x squared ln x. So the first step is check the form of the question. The limit is an indeterminate form. So the second step is rewrite the question as a fraction, which is x squared ln x becomes ln x over 1 over x squared. Since the limit is x towards 0 positive, so that means ln x is negative infinite and 1 over x squared is positive infinite. So we have negative infinite over positive infinite as a form. This means L'Hopital is applied. So step 3, differentiate numerator and denominator. And the equation will become limit x towards positive 0, 1 over x divided by negative 2 over x cubed. Then simplify the equation and it will become negative x squared over 2. After we simplify the equation, we can evaluate the limit. So limit x towards positive 0, negative x squared over 2 equals to 0. So the final answer that we get is 0. For the last question, limit n towards infinity and e to the power of 2n. So the first thing that we have to do is rewrite the equation to apply L'Hopital rule. So the equation will become limit n towards infinity and divide by e to the power of negative 2n. As n approaching infinity and the denominator is infinity and denominator is positive 0, so that means L'Hopital rule is applied. The next step is to differentiate the numerator and denominator. So the equation will become limit n towards infinity 1 over negative 2 e to the power of negative 2n. And the last step is we can evaluate the limit as n approaching infinity. That means e to the power of negative 2n equals to positive 0. So the answer that we will get from this equation is positive infinity.